Hey guys, this is Nagarjun, data science intern at the Sparks Foundation. As a part of this internship, there were several tasks. I have chosen task 2, which is prediction using unsupervised ML. The problem statement says to predict the optimum number of clusters and to represent it visually from the given iris dataset. So I've used a Python programming language. So let's just see the dataset and get into the code. So this is the dataset I have been given. So you can see sepal length, sepal width, petal width, everything is in centimeters, and species is mentioned like Iris setosa, Iris versicolor, and Iris virginica. So let's just get into the code. So I've imported all the necessary libraries: NumPy SNP, Pandas SPD, Matplotlib, Seaborn, and sklearn. I've imported k-means. So I've loaded the dataset using pandas and the read CSV method. So I just got the summary of the data using data.info. It says it has got 150 columns and 150 rows and 6 columns. So for the clustering problem, we actually don't need the labeled name, which is species. So we'll just drop the species column and ID, the next cell. So after dropping the ID and species column, now it says it has got 150 rows and 4 columns. So just to ensure the data, I use data.head method. So the task was to find the optimum number of clusters. So we'll see how we can do that using the elbow method. So we'll compute the clustering algorithm for different values of k by varying k from 1 to 10 clusters. And for each k, we will calculate the total within cluster sum of square, which is WCSS. So I've given the cluster number as 10, but it can be arbitrarily given. So I used a for loop here, and k-means have given I. I've fitted the data. I used k-means.inertia and appended that to WCSS. So I'll plot the elbow method in the next cell. So the title I have given as elbow method, x level as number of clusters and y level is within cluster sum of squares. So as we can see that as the location of bend in the plot is generally considered as an indicator of the optimum number of clusters, so we can conclude that the number of clusters for this given data set is 3. So we'll fit the data and we'll see how it is visualized in the next cell using scatter plot. I've used sepal length and sepal width to see how the data is being distributed. So we can see the data is distributed into 3 clusters. Thank you.